Scalar multiplication. Scalar multiplication is one of the basic operations defining a vector space in linear algebra. In common geometrical contexts, scalar multiplication of a real Euclidean vector by a positive real number multiplies the magnitude of the vector without changing its direction. It is known as the product of real numbers and the basics of matrix. In scalar multiplication, each entry in the matrix is multiplied by the given scalar. Here's an example using matrices. So A is equivalent to 10, 6 and 4, 3. Finding 2A. 2A would be 2 times the two coordinates, giving you 20, 12, and 8 and 6. Dot product. If we break down the formula factor by factor, the first two are magnitude A and magnitude B. These are the magnitudes of vector A and B. So the dot product takes into account how long vectors are. The final factor is cos theta, where theta is the angle between vector A and B. This tells us that dot product has to do with direction. Specifically, when theta equals 0, the two vectors point in exactly the same direction, not accounting for vector magnitudes. This is when the dot product is at its largest, because cos 0 is 1. In general, the more two vectors point in the same direction, the bigger the dot product between them will be. In most questions, we typically only have coordinates of A and B. Calculating magnitude A, magnitude B cos theta would force us to find two square roots and a cosine, which is a lot of work. Luckily, there is an easier way. Just multiply the corresponding components and then add them like these examples. This is for R2. The formula for having two coordinates A dot B is A1 times AB plus A2 plus B2. In that following example on the right, you will get an answer of 2. This is the same question, but for R3, where the formula of A dot B is A1 times B1 plus A2 times B2 plus A3 times B3. And on the right is the same coordinate system, but instead R3, getting A dot B equivalent to 10. Cross product. Cross product is between two vectors, same A and B, but it's pronounced as A cross B. Unlike dot product, which returns a number, the result of cross product is another vector. Let's say vectors A crosses with vector B to get vector C. Firstly, vector C is perpendicular to A and B, also known as the normal in planes. With this, you can say that C dot A and C dot B are equivalent to 0. Cross product only works in R3. In R2, there isn't always a vector perpendicular to any pair or other vectors. The length of C is a measure of how far apart A and B are pointing, augmented by their magnitudes. It's similar to dot product, but instead it uses sine theta in the formula, where theta is the angle between A and B. When the angle is 90 degrees, the cross product is at its largest. In a sense, dot and cross product complement each other. If you hold up your right hand, point your index finger in the direction of A and point your middle finger in the direction of B and your thumb in the direction of A cross B, you would have the right hand rule. This hand gesture is used to give you a visual of the graph to better understand the directions of the vectors without having to draw the graph in R3. This is the cross product formula, where it looks very daunting. You are given two coordinates, both in R3. A cross B is equivalent to A2 times B3 minus A3 minus B2. Second coordinate would be A3 times B1 minus A1 times B3, and the z coordinate would be A1 times B2 minus A2 times B1.